Good day, viewers. Welcome to Brimstone Tutors. My name is Sahid Ogundeji. So, what we have today, we want to talk about chemistry, and the topic that we have today is redox reaction. Of course, we all know redox reaction, but we want to actually emphasize on balancing redox reaction. How can we balance a redox reaction? It's very simple. I'm not going to stress you much because I'm just going to go straight to the point. Now, to balance a redox reaction, there are two simple ways. The first way, we divide the equation into oxidation and reduction. And what do we actually mean by oxidation? Oxidation simply means loss of electrons. The substance that is actually undergoing oxidation has to be reduced. Now, what we mean here, they ask us to balance this redox reaction. I told you the first thing we just need to do is that we should just group them into two. We group them into oxidation and reduction. So this is the reaction, ionic equation of the reaction. We have this, then gave us Fe2 plus Ag solid. Now, always remember that oxidation simply means loss of electron, while reduction simply means gain of electron. The substance that is being oxidized will always reduce in terms of oxidation number, while the substance that undergoes reduction has to be oxidized. That means that it must increase in oxidation number. Always remember this thing: oil rich. Oil rich. Rich simply means oxidation is loss of electrons, while reduction is gain of electrons. So now, let's now move to what we have here. So what actually happens here is what actually happens here is oxidation. So now the substance that has been oxidized is the reducing agent. You can see here the oxidation number here is 0. Look at it because it has no charge. It's a solid state. Why? After it has been oxidized, it produces +2. That means the oxidation state of this at the product side is what is +2. And also, let us also from here to here is what is reduction. So now here, and it has been reduced to what? To 0. So it is +1 here, but here it has been reduced to 0. Here, this place is 0, and at this side it has been what? Oxidized to 2. So once it's undergoing oxidation, it reduces. The oxidation number of that substance will reduce. While once it's undergoing reduction, the oxidation number of the substance that's actually undergoing that oxidation has to be what? Oxidized, and it has to be increased. Like what we have here. So now, the next thing I now have to do is that I have to group them into two. So I have to group this into oxidation. This is my oxidation. I have Fe produce Fe2 plus. Now, in balancing redox reaction, there are two things that is very important. The first thing that is important is that we need to balance the charges. We also have to balance the atoms. So we have to balance the numbers of atoms. We also have to balance the charges. So there are two things that is very important and very paramount for us to do. So now I have to balance the charges here. Here, the number of charges here is 0. Why the number of charges here is what? Is +2. Here is +2. Now, in order for me to balance this, I need to add 2 electrons to the left hand side so that it's going to have the same number here. So remember, electrons are always negative charge. So if I had 2 electrons here, that's +2 minus 2, that's 0. So if we have the same numbers of charges that we have at the left hand side. So I can also actually have Fe. Here is going to be Fe2 plus. I'm going to have 2 electrons here. So now, for me to have 2 electrons here, you can see that it's now balanced. +2 minus 2, we have 0, which is we have at the left hand side. Also, if you also look at the numbers of atom count, is also correct. We have 1 ion, we also have another 1 ion. So now, that is for the oxidation state of it. We also have to look at the reduction. For the reduction side of it, I'm trying to what? Here we have Ag. So the oxidation number, to make this place to have the same oxidation number to what we have here, I need to have the same charge to what we have here. I need to add an electron, just a single electron to this side. So now this place will now become Ag plus. Let me segment it into. Then I'm going to have plus electron. There I'm going to have Ag. So now there are two things that need to be done here. Now, for us to have a balanced ionic equation, the numbers of electrons I have at the oxidation must be equal to the numbers of electrons I have at the reduction. So in order for me to do this, I need to multiply, because here we have two electrons, but here we have just only one single electron. So in order for me to make the electrons to be equal, I need to multiply all what I have here by 2. So now I'm going to multiply all this side by 2. I'm going to multiply by 2. I have 2 plus 2e minus, I have 2ag. Now you can see now we now have equal numbers of electrons. So now I might have to add both of the two electrons together. That means that I'm going to add both of them together. Let me call this to the side. I'm going to have 2ag plus 2e minus, right? This will give me 2a subscript g. So now, in order for me to make this thing happen, I'm just going to add both of them together. I'm going to have Fe, that means that the two reactants, I just bring this, I just bring it here. I have Fe plus 2Ag plus 2E minus. Then I'm also going to add the product side together too. I have Fe2 plus 2Ag, or anyhow you do it, plus 2E minus. So now you can see that I have plus 2E plus 2 electron plus 2 electron at the other two sides, at the both sides of the equation. So the next thing I have to do, that I'm just going to take both of them away. I'm just going to subtract minus 2 from both sides. So now the balance equation of my reaction is Fe plus 2Ag plus produces Fe2 plus 2Ag. So this is the balance equation of my what? Of my redox reaction. So I'm going to clean this. So the next one that we're going to do here again, this time around, I'll give you this one. You should practice this yourself. I've done this. I'm also going to do this. Now, this is the complex form. These are simple ionic these are simple ionic equation, but these are complex ionic equation. In kind of case, there's a way in which we balance them. So let us go to this form. So they ask us to balance this. How can we do that? I'll also do the same thing. I'm going to have MnSO4 minus plus SO2. It produces manganese 2 plus SO4 2 minus. Now, to make this thing done, the first thing we do here, we calculate the oxidation number of manganese that we have here and what we have here. Remember, the oxidation number of manganese that we have here is just plus 2. I need to also look for the oxidation number of manganese that we have here. Sorry, it's just... So now, here, this is the tetraoxo manganese 7, but let me just calculate it for you how to get it. So this is just Mn plus, we all know that oxidation number of oxygen is minus 2. I have minus 2 times 4, because we have 4 atoms of oxygen, which is going to be equal to the charge. The charge is there is minus 1. So now here we just calculate Mn minus 8 equals to minus 1. Then Mn equals to minus 1 plus 8. Then Mn is equals to 7. So here the oxidation number of manganese that we have here is 7. While the oxidation number of sulfur here is minus 4, or is plus 4, sorry. So you can just calculate it. It's just S plus minus 2 times 2 equals to 0. Since it's a neutral atoms, since it's just a solid, is a neutral, is a gas, right? So now here it's just that. So we have S minus 4 is equals to 0. S equals to 4. It is equals to 0 because it's just a gas. When we are dealing with solid, gas, or liquid, so their oxidation number is always 0 because they are in their balanced state. So now here we have S equals to 4, and the same thing I'm also going to have here. I'm going to have the oxidation number of what we have here to be S of sulfur here. I'm going to have minus 2 times 4, and which is equals to minus 2 because it must be equals to the charge that we have here. Then I have S minus 8 equals to minus 2. Then S equals to minus 2 plus 8. S equals minus 2 plus 8 will give me 6. So the oxidation number of this is 6. Now, we move on. You can see that the oxidation number of manganese that we have here is 7, while here is plus 2. So this reaction here is reduction. I think that what manganese 7 is reducing to what? Manganese 2. Then also, the substance that always undergoes reduction is always known as what? Oxidizing agent. The same thing also I'm going to have here. Here we have 4, here we have 6. So what will actually happen here is what? Is oxidation. Oxidation. And the substance that undergoes oxidation is called reducing agent. As simple as that. So since the moment you're able to differentiate them, I can now solve them separately. I'll balance the oxidation side. I'll also balance the reduction side. Let's move on. I can say that this is MnO4 minus produce Mn2 plus. So this is for the what? This is for the reduction. I'm also going to do the same thing for oxidation. For the oxidation side, I'm going to have SO2, which will produce SO4 2 minus. Now, let's continue. So what we have here, we now have to, since the moment you have oxygen in this kind of cases, you now have to add hydrogen, you have to add water molecule to the side that lack oxygen. You can see the numbers of oxygen that we have here is 4, but this side has no oxygen at all. So the side that has no oxygen, you add a more water molecules there. So now, to balance the oxygen that we have here, so here I'm going to have MnO4 minus. So here I'm going to have Mn2 plus. I'm going to balance it with the water molecules. So the water molecules I'm going to use 4H2O. This is why we use 4 because we have 4 atoms of oxygen. Then 4 times 0 will also give me 4. So we have 4 moles of oxygen here. So which make it to be equal. This is 4 atoms of oxygen. It's balanced at the both sides. So after that, what we now have to do, but now we now have hydrogen at the left hand side, at the right hand side, sorry. We need to have hydrogen at the left hand side too. So to have hydrogen at the left hand side, we need to add hydrogen ion to the left hand side. So now I'm going to have MnO4 minus plus, how many hydrogen atoms do we have? 4 times 2, that is 8. So I'm going to add 8 hydrogen ion here, so like to balance what you have at the left hand side, plus 4H2O. Now the next thing I now have to look at, since you can look at this, manganese is 1 atoms. If you also look at the hydrogen atom is 8, 4 times 2 is 8. We are doing one of the atom count 4. It's balanced at both sides. So the next thing I now need to look at, their charges. Like the charges I have here is what? -1 plus 8, which is 7 charges. Also, the charges I have here is 2 plus 0. So here is lagging. We have more of charges here compared to this. So I need to add electron here. So this is 2. This is 7. We have more of charges there. So I need to add 5 electrons here to balance what we have at the left hand side. So now I'm going to have MnO4 minus plus 8H plus, then plus 5E minus. So here I'm going to have Mn2 plus 4H2O. Now, the next thing we now have to look at, since we have 5 electrons here, then we have this, it is now balanced. So the atom count is balanced and the electron at both sides is also what? It's also balanced. So we also move to this side also. Here also, we have oxygen at both sides. So we add hydrogen atom to the side that is lagging what? We add water molecules to the side that's lagging oxygen. This side is lagging oxygen. So I need to add water molecules here. So I'm going to have something like this. I have SO2 plus what? Water molecules. That's we have 4 oxygen here, so I just need to add 2 H2O. So it is complete like that. So 2 will give me, so we have SO4 2 minus. So that's complete. That's 2 times 2 is 0. 2, we have 2 oxygen plus 2, that is 4. Then we also have 4 hydrogen. So I now need to add hydrogen ion to the side that is lagging what? Hydrogen. So I need to add 4 hydrogen ion to the left hand side. So I'm going to have SO2 plus 2H2O give me SO4 2 minus, then plus, yeah, the hydrogen ion I'm going to add there, I'm going to have 4H plus. Just like what I did there, I'm just going to do the same thing on the other side there. So now, the next thing I have to have here, and I need to do my what? My atom count. If you look at what I have here, yeah, the atom count I have here is 0. Because sulfur 2 oxide is 0, water molecule is 0. The carries no charge. But if you look at this side, the charges that we have here is plus 2. Because this is minus 2 plus 4, that is plus 2. Now, the next thing for me to do here is that I need to make sure that what I have at the left hand side is equal to what I have at the right hand side. So I need to add 2 electrons to the right hand side. So I'm going to have SO2 plus 2H2O. This will give me SO4 2 minus plus 4H plus minus, then we have minus 2E minus. So now it is now balanced. If you look at what I have here and what I have here is now balanced. But if you also have to look again, we can see that we have 5 electrons here, but we have 2 electrons, and both of them has to be equal. So the first thing we do here is that we just try to do it as if the way we used to solve our normal what? Simultaneous equation. So I'll multiply all what I have here by 2. I'll also multiply all what I have here by what? By 5. I'll multiply all what I have here by 2. I'll multiply all what I have here by 5. So because the numbers of electrons that we have here is what? Is 2. Why the numbers of electrons that we have here is what? Is 5. So I'll multiply it like that. So I'll multiply the whole of this by 5. I'll multiply the whole of this by 2. So now, my results that I'm going to have this. Please, quickly jot down all what I have here. I'm going to have something like this. We have done this when you are through with this. So we can now move again. As we all know that we have to multiply all through of this by 5 and this by what? This by 2 and this by 5. So the next thing we now have to look at, we say that this is going to give us 2MnO4 minus. I multiply 2 by this, that's plus 16H plus, then plus 10E minus. So the same thing also goes to the other side also. I'm going to have then I'm going to have 2 times this. I'm going to have 2Mn2 plus, then plus 8H2O. So I'm going to use these two to, as I use these two to multiply all through what we have here, we're also going to use this 5 to multiply all what we have here. So here it becomes 5SO2 plus, here is going to be 10H2O. Here I'm going to have 5SO4 2 minus plus 5 times that's 20H plus, then plus 5 times this will give me 10E minus. So now, if you can see, this we cancel this automatically. Then what I have here, I'm just going to sum up both of them together with what I have at the other side also. So now also, if you also take away this, I can say that this here this here will become 0, then and this place will become plus 4 in terms of hydrogen ion. So I'm going to have plus 4 hydrogen ion there. So here I'm just going to have 2NNO4 minus plus, there's no longer any hydrogen ion here again. Then I'm just going to plus 5SO2 plus 10H2O. If you look at this H2O also, I have 10 here. This can be what? 0. And I don't know, if I take away 8H2O from both sides, this will become 2, right? I have 2H2O. Then here at the other side, I'm going to have 2Mn2 plus 5SO4 2 minus, then plus, don't forget we have 4 hydrogen atoms term here. Then that is all about that. So this is the end of the equation of the ionic balancing. This is the balance equation. So that's, thank you very much. I really appreciate for listening. Don't forget to subscribe, like, and follow. See you in our next class. Bye.